Good day and welcome to WIDS-TT's series aimed at preparing you for the next wave, a Youth Climate Data Challenge. For this challenge, you are required to design a data-driven prototype based off your proposal. To do this, it's important to understand what data is available to you and how to use it. In this first video, we will discuss the data landscape. By the end of this video, you should be able to understand the different types of data, be able to locate key sources of relevant data available online, be able to locate sources of data specific to the Caribbean, and be able to choose the most appropriate data sets based on desired outcomes. Let's start by discussing the types of data available to you. For this challenge, depending on the type of tool being designed, the following types of data may be relevant: climate data, geospatial data, demographic data, and public health data. Before we discuss each type, I'll mention that data is commonly stored in tables, which are sometimes called data frames. Each row represents an observation or a record. Each column represents a different variable or feature of the data. In the following videos in this series, you will learn more about manipulating data like this. Sometimes, when downloading data, there may be companion files that explain what the dataset is about and what the columns represent. You may also observe that there are different types of data files online available for download. These include Microsoft Excel workbooks, which use the file extension XLSX, comma-separated value files, which use the extension CSV, and extensible markup language files, which use the XML extension. These may be opened in spreadsheet software such as Microsoft Excel and Google Sheets. They can also be loaded into programming software such as Python and R for different approaches to analysis. Firstly, climate data involves observations of Earth's environmental conditions over time. These include temperature, humidity, wind, rainfall, sea level, and many other types. Each of these features of climate data may be used to derive different insights. For example, temperature data may be used to monitor global warming, while rainfall and sea level may be used to predict flooding risk. When looking at climate data, we may find temporal or time series data, or we may find geographic data. Temporal data can be used to discover trends and predict what might occur in the future. Geographical data may be used to determine which countries or regions are most vulnerable to climate change and extreme weather events. It's possible to combine two datasets together for more detailed analysis. However, there are many datasets which already show temporal and geographic data together. So let's discuss climate data first. Climate data can be used to investigate trends in global warming and climate change, can be used to derive insights into resource allocation and risk management, and it can be used to inform planning and policy making. For certain tools, using geospatial data may be more appropriate. Geospatial data refers to data involving locations on the Earth. Common features are coordinates, descriptions of what each observation records, and time data, allowing for the analysis of trends over time. Geospatial data can be used together with Geographic Information Systems, or GIS, tools to create useful maps and visuals. However, using geospatial data may be advanced for beginners. An important part of this challenge is to include an aspect on gender and inclusion. Demographic data involves data about people living in a particular area. Features of demographic data include gender, age, employment, religion, and ethnicity across locations. These can be used to derive insights into the most vulnerable groups. Lastly, some projects may find that using public health data might be useful. This includes data about diseases, births, deaths, living conditions, etc., of people in different areas. Public health data is linked to demographic data, and it can be used to determine those groups most affected by diseases and conditions. Remember that these types of data are all linked to each other and can be used together to create more extensive solutions. For example, air quality, which can fall under climate data, may affect the prevalence of respiratory illnesses among certain demographics in certain areas. In our video on cleaning and preparing data later in this series, we will look at some ways to join different datasets together. Additionally, many datasets will already include more than one of these types of data. To test your understanding of what we've discussed thus far, try these questions. First, other than those mentioned, what other types of climate data can you name? Also, give an example of how demographic data and public health data can be linked. Moving on, let's discuss how we can locate these types of data. Data can be classified as real or synthetic. Real data is data that was actually collected from people or the environment by reliable individuals or organizations. Synthetic data is data that was artificially generated. While synthetic data may be similar to real data, it does not contain any actual records. For this project, it's important to use real data when investigating trends and insights. Synthetic data should only be used for simulation or for demonstration of prototypes. To obtain data for your project, there are numerous sources online that provide open data for public use. These include the UNFPA Data Portal, the UN OCHA Humanitarian Data Exchange, OpenStreetMap, and NASA Earth Data. On the UNFPA Data Portal, you can find data related to sexual and reproductive health, inequality, education, and other topics. On the Humanitarian Data Exchange website, you can download data on climate, disaster, and vulnerability. You can also filter the data by location, format, and organization. On OpenStreetMap, you can navigate to different geographic locations in the world and download geospatial data for that area. You can also use this data in GIS software such as QGIS for analysis and creating visuals. On the NASA Earth Data website, you can download environmental data in a variety of formats. There are also several filters available to make searching the data easier. If you are developing a community-specific tool, insights from members of the chosen community are important. In that case, it may be useful to gather your own data using websites and applications such as Google Forms, Microsoft Forms, Kobo Toolbox, and other mobile data collection apps. These applications allow you to create your own surveys and questionnaires and share them via links. Tools such as Google Forms, for example, allow you to view the responses on a spreadsheet, which makes analysis easier. As this challenge is aimed at the Caribbean region, let's look at some Caribbean-specific sources of data as well. Several regional bodies collect data on different issues affecting the Caribbean, including climate, inequality, education, and more. These bodies include National Statistical Offices, the CDEMA, CARICOM, and Caribbean Atlas. For example, Let's take a look at the Trinidad and Tobago Central Statistical Office website. We can find the data on population, environment, and economics in Trinidad and Tobago. Navigating to one of these pages allows you to download this data in Excel format. To test your understanding about what we've discussed, try to look for your country's National Statistical Office's website online. See if there are any available datasets that are linked to your topic. To conclude, let's discuss how to choose the right datasets. Once we find the datasets related to our desired topic, we can evaluate them based on recency and coverage. More recent data provides the most relevant picture of the world today, so should be preferred to the older data. Therefore, the dataset shown on the right would be better to use than the one shown on the left. As for coverage, having more complete data means that more accurate insights and predictions can be obtained. Therefore, data which has less missing values and covers all the desired features is more beneficial. It's important to remember that gaps are findings too. Is there a territory in the Caribbean with little data on gender inequality? What about a community without data on how flooding affects the occupants? These can be important areas of research. When you come across such gaps, think about what groups and organizations would be best suited to carry out the required research. In summary, in this video, we learned about climate, geospatial, demographic, and public health data and what they can be used for. We learned how to source data from reliable sources online, and we learned how to evaluate our sources to choose best suited to our goal. Thank you for watching this video. We hope it was helpful in preparing you for the data challenge.